Now comes the moment we've all been waiting for, where the modern periodic table comes from. While Mendeleev has gotten the credit for the creation of the modern table, there was a scientist who had similar work around the same time. German scientist Lothar Meyer wrote a textbook in 1864 which featured 28 of the elements at the time, ordered by valence. Meyer later came up with an extended table he gave to a colleague in 1868, but was a year late to be published in 1870, as Mendeleev's work was published in 1869. Also notable from 1864 was a table created by a scientist by the name of William Audling, whose table was remarkably similar to that of Mendeleev's. Audling didn't make much press, however, as he had a big part in trying to discredit John Newland's table. Dmitry Ivanovich Mendeleev, a Siberian-born Russian chemist, was the youngest of 17 children and is known for his periodic table, but has many accomplishments under his belt. I was fortunate enough to be able to swing an interview with this great man of science. Mr. Mendeleev, thanks for coming. Thanks for coming out here, and you're heralded as the father of the periodic table, and I'm kind of a big fan of the periodic table. Can I call you Daddy? Good. Maybe a hug. All right. Okay. But well, let's get down to business. I'm gonna play hardball with you, Dmitry. A big reason you take the share of the credit for the first periodic table over Lothar Meyer is because of your predictions. There were only 63 known elements at the time you put together that table, but you predicted atomic weights for such elements later to be discovered, such as gallium, germanium, scandium. My question is, why didn't you make the correct predictions for the remaining 51 elements?
Well, I don't understand.
Next question. You were married to one Fyodosva Nikitishna Lishevya in 1862, and then you became married again in 1882 to one Anna Ivanovna Popova while you were still married to your first wife. Explain yourself.
I wandered into a church and Popova was there. I don't even know.
Next question. You were one of the founders of the Russian Chemical Society. You helped with the creation of the first oil refinery in Russia. In 1893, you formed the new state standards for production of vodka, and you were also credited with introducing the Russian Empire to the metric system. Of all these, what do you consider your greatest accomplishment?
Definitely vodka.
Vodka. That's what I thought. Which brings me to my next point. Do you contribute all your success to your love of the reefer as portrayed in this portrait here of you?
This is obviously propaganda for my first wife.
Alright, so I made that last part up about the reefer. I was just kind of fishing for...
I think this interview is over.
Oh, we're through, huh? We're through, alright. Just like you're going to be through in 1907 when you die of influenza.
What?
How do you like that?
I kill you! Now!
No! Please! Back to the Meyer-Mendeleev debate. Meyer may have started earlier, but there are a few reasons why Mendeleev's table was superior. For one, Mendeleev's table was organized not just by valence, but by atomic weight. Mendeleev's table was also able to dispel existing atomic weights as incorrect and predict elements not yet discovered such as germanium, scandium, and gallium. Come 1895, the first reported discovery of a new gaseous element, named argon, was discovered by Lord Rayleigh. This came as a shock as the element didn't fit in any of the known periodic categories. 4 years later, Sir William Ramsay proposed the element be placed in its own group with helium, called the zero group, also known as the noble gases. Ramsay is also credited with the prediction of the properties of neon. Although Mendeleev laid the brickwork, it wasn't until the 20th century that it was found out why the properties of the elements recur periodically. Ernest Rutherford, also known as the father of nuclear physics and a Nobel Prize winner, wrote a paper which led to the finding of nuclear charges in 1911. That same year, amateur physicist Antonius van den Broek, he was a real estate lawyer by trade, wrote 2 papers that proposed the atomic weight of an element was equal to the charge on the atom. This charge is what we now call the atomic number, the number in which the elements are organized on the periodic table. As 1913 came, Henry Moseley came with it, with his idea that the ordering of wavelengths of X-ray emissions of the elements coincided with the ordering of elements by atomic number. With the discovery of isotopes in the elements, it was found that the properties of elements varied periodically with atomic number rather than atomic weight being the basis, as Mendeleev, Mayer, and Adling had proposed. As the decade passed, the answers to the reason for periodic law became apparent through the work of a few scientists, from Niels Bohr's studies of the organization of electrons into shells to G. N. Lewis's discoveries of bonding electron pairs and Lewis dot notation. The last major changes to the periodic table to date came from another Nobel Prize-winning scientist, Glenn Seaborg. Seaborg discovered plutonium in 1940 and went on to discover elements 94 through 102. He also configured the table by placing the actinide series below the lanthanide series against the advice of fellow scientists. He won the Nobel Prize for Chemistry in 1951, and element 106, Seaborgium, was later named after him.
So that was that. That's the whole deal with the periodic table. Hope you're more enlightened now. And I hope you get a thirst for knowledge like I do and just read your chemistry book as often as you can. Well, and speaking of that, if you'll excuse me, I'm gonna just get back to this. So see you later. Go ahead and let yourself out there. The dog won't bite. Just I'll see you later. Let me know if you don't have a copy of this. Go ahead. I can direct you where to get one at the local bookstore. Or I recommend taking a chemistry class, preferably Miss Fantine if you can. She's probably the best chemistry teacher ever. So anyways, I'll see you later. I'm just going on and on. So just go. Get out of here.